Hi there, I'm John McMillan, and welcome to this edition of PCB Tech Talk, the podcast where I'll be talking about design tools, the EDA industry, and the questions you've been asking. I'll be bringing in special guests from time to time, including subject matter experts and EDA industry leaders. So be sure to subscribe to this podcast. Let me know the topics you'd like to discuss, and if you'd like to be my guest right here on PCB Tech Talk. So today, I welcome back David Wiens to talk design trends we're experiencing today and what the future trends are for PCB design. You may recall that Dave joined a few podcasts back to talk about PCB design competition called the Technology Leadership Awards. I think we call them the TLAs.
Correct,
right?
correct, yeah.
And it's the longest running PCB design competition of its kind, right?
It's the only one that I know of.
The only one?
Yeah.
Wow. Okay. So welcome back, first of all.
Thanks. Good to be back.
I think one way to get a good cross-section of current PCB design trends is asking you what you've been seeing for submissions for the TLAs.
Sure.
I guess you and the judging committee are hard
Yeah. It's the designs are actually with the judges as we speak. I think we talked a little bit about that last time. We've got 8 industry judges, esteemed guys from the industry that represent, 300, 400 some years of design experience, so it's pretty awesome. Anyway, the designs are off with them, so they get to do their hard work. I gave an early Christmas present, so they get to do some work over Christmas, and then we'll get back together and announce the winners sometime mid-January.
Oh, awesome! So first off, would you describe as any more like cloud-based Bluetooth, Wi-Fi stuff? I walk in Home Depot, for example, there's like an end cap now dedicated toward all these home electronics. Everything's Bluetooth compatible. Yeah. It seems like you buy all these devices. Are you seeing any of that?
The whole Internet of Things.
Yeah,
approach.
exactly.
What we see a lot of, those sorts of, the real IoT things that the consumers see tend to be lower technology. I don't hope I'm not insulting anybody there. The real meat of that is the data centric. The servers, things like that in the background. And in general, this year we didn't see a lot in that spectrum. We did see some servers, but because our, the designs that are, in our customer base represent, the full gamut of the electronics industry, we see a lot of things. Things from, oscilloscopes, radar systems, on the consumer side, infotainment systems for cars,
nice.
Consoles for cars, console systems for cars, solid state drive. You wouldn't recognize any of these, any of the designs because they're all in the background of something, unless say you were to drop your solid state drive, but they're all there, and they, but a lot of things come from, say, the Mill Aerospace, telecom, things where we all appreciate, the performance we see, but we don't really know what the electronics are behind the scenes.
Gotcha.
And so that's, let's see if I can think of any other ones: flight computers, satellite systems, infrared image processing. Computers on modules, high-end camera sensors. That's another consumer type.
Sounds like a lot of Mill Aero stuff this year.
There's a fair spectrum of that, but it is. It represents. We've got 6 unique categories that we track. But it represents the full electronic spectrum in the industry. So
great. So what do you see challenges being faced by design teams?
So if you look at this stuff, it's not something that necessarily changes from year to year. Certainly, we've got a market that is certainly growing, but it's also got a mature set of technologies out there. But in terms of the challenges, it could measure in terms of cost, density, design time, and performance. Really, is the 4 broad categories, and I could go into a little bit of each of those if it makes sense.
Yeah, that'd be great.
Okay.
Yeah.
We got time. Okay.
Densities. That's a huge, because
Yeah.
each year we see denser and denser, more compact designs, more density.
Yeah, I had an example this year. Somebody said they had a design that had the same functions as the previous design, but it was supposed to be done in a quarter the size of the previous design with 3x the speed performance requirements. So that's the way it goes. Either you get the same set of functionality in smaller, denser, faster, or you get the same form factor and you're told to 2x and 3x the functionality on the design.
Right.
So and that's the sort of thing from year to year that designers face.
So how do they accomplish that? How can they reduce the downsides?
So there's a lot of technologies at play there in terms of advanced approaches. HDI certainly it's not a new one, but it's been around. We see year on year typically HDI is at around 40 to 50% of the designs anymore. So it's pretty much commonplace. But HDI fights against another challenge, which is cost, because HDI is still a more expensive approach than through-hole. So while it solves a lot of density problems, it actually introduces another challenge in terms of cost. And some of the more complex designs we see actually don't use that kind of advanced technology. And somebody who's got a double-sided board that they did with pure through-hole, with the tons of planes that we see in designs today, they're just making Swiss cheese out of them. That's pretty impressive stuff.
Yeah, I remember when blind and buried vias were a challenge versus through-hole technology because manufacturing processes weren't cost-effective yet.
Right.
So how far are we along before we get to the point where HDI is so commonplace that it's meeting that kind of thing?
Certainly by virtue of becoming more common, its cost is going down. So it's that's what's going to drive it ultimately, and that's what has driven it to this point. It's technology that's been around my entire career, which is look at my hair. It's you can tell.
My lack of hair.
Or you just shave it and make it easier.
Yeah.
Okay.
Exactly.
Okay. But other things we're seeing in terms of this density, just to talk density a little bit more, the power distribution networks. That's probably the single biggest thing that I see changing year on year. And it's gone from, I did a little bit, looked at some numbers. This year we had an average of 18 rails on a design. And a max of 84. Now those numbers are actually low. I've seen numbers in the hundreds. But then I go back 7 years and I saw some designs where the average was six rails and 60. And we're both old enough we can remember designs that only had one rail, right?
Right.
So that when you throw that many PDNs on the design, you're fragmenting up the plane layers. There really isn't such a thing as a solid plane anymore.
Right.
And it messes with the ability just to get power to the devices, to have clean power, to minimize voltage drop. And at the same time, the power consumption is up, and therefore the heat dissipation becomes a problem. And so all of these things in a tight form factor really play against each other. And another one I saw in there, integrated RF. I mean, that's another density issue, right?
Right.
Trying to get as much onto a board as possible. And that's been something people have been integrating for a while, but it's becoming more commonplace again to see.
Right. So time, performance.
Okay. Well, cost. I'll hit cost first.
Okay.
I talked a little bit about it, but it's the common drive to reduce board layers, and you can generally tell, or at least you used to be able to tell, what industry somebody was in. If they said, I had a 24-layer design and I just couldn't quite get everything, and I had some performance issues, so I had 4 more layers. It's like, you're in mil-aero, aren't you? But that's not the case anymore. Even mil-aeros are faced with cost pressures. So really, everybody is getting the drive to reduce layer count. That's a cost issue. That becomes back to the density issue. Using standard materials perhaps don't have the best performance, and so you've got to do some workarounds.
That's where HDI comes in too.
Sure,
really reducing layer count.
Yeah, it is. And then back to that through-hole example again. Where you're trying to minimize. So some of the toughest designs that we see are actually designs that you think on the surface are the simplest. Like a 2-layer through-hole design. You go, oh wow, isn't that very almost 19th century, right? It is 19th century, but those can be some of the most complex designs that are out there. Time. As far as time pressure, I mean, it's a common thing, right? Everybody's got a schedule, got a deadline, and like I said, even the Milleros of the world are getting hit with cost and time pressures. So it's driving everybody. And this year we saw the minimum time somebody did was 1 week, which is quite impressive. The max was 75 weeks. So going over a year.
Those new designs or
new designs? Wow. Yeah, and the average was 15 weeks. So, and the longest times, for what it's worth, were in the telecom space. They're around, an average of 26 weeks.
Yeah.
But and this is driving a lot of change, and we can talk maybe some later about best practices. But things like reuse, concurrency within the team, collaboration, even adding validation steps to the design process. Which is kind of counterintuitive because it adds time to the design process, but it cuts down on cycles. So these are all things that that we see going on, really across the whole industry. Last, in terms of performance, everybody knows the faster. When we got to go faster, we got to put more functionality in, and some of the things that we saw expressed were that some design teams were almost flying blind with some of the new technologies that are out there. Things like hybrid memory cube.
What do you mean by flying blind?
They're meaning there's not a lot of industry expertise to this point.
Okay.
You can follow the progression of DDR. DDR2 was new one day, right? And then DDR3, now DDR4, and then into hybrid memory cube. And with each one of those, they become, the industry kind of grows around it and helps support, and people can train on it. But when you got guys trying to adopt some of the latest technology, they really have to learn on their own, and that's by flying blind.
Sure. Okay.
Yeah. So yeah. DDR4 still to some degree that way, PCIe, Gen 3, SerDes technologies. But the easiest way to judge performance is in terms of the number of high-speed nets. We see, the highs being at like 90%
wow.
on high-speed constrained nets. That's pretty much everything but your supplies, right?
Exactly, yeah.
So that adds just a ton of complexity to the design process all by itself, along with those PDNs to supply, clean multi-rail power.
Mm-hmm. That's a lot of challenges when you do the such highly constrained designs.
Yeah, sorry, I'm choking up.
I'm gonna go eat some more.
But yeah, you talk about the challenges, and one of the interesting things I like to watch is, what is a design team? It's not just what they're building, but how they do it. Mm-hmm. And the judges, for what it's worth in this competition, are really interested in seeing this sort of stuff as well. So, we spend a lot, we put a lot of questions in there asking them, how did you do it? Mm-hmm. And it's not intended to, make people give away trade secrets,
right.
But one of the cool things about engineering is overcoming challenges, right?
Sure.
Nobody wants to do the same thing they did yesterday. They want to try something new. And so there's a lot of trade-offs at play there, and things like power distribution versus breakout routing. A good breakout pattern can just blow up a plane underneath it. Mm-hmm. Layer limits versus clean SI. Everybody wants to do nice strip lines.
You talked about breakout patterns and the impact it has like on rails and just everything else. Is there a flow or process that's coming into play that enables them to accomplish things by doing them in a certain order on these challenging designs?
Well, certainly people have their processes. Mm-hmm. They will do certain critical, critical signal profiling up front to be able to understand what they're in for. Mm-hmm. They'll try to do it before they go, get too far into the layout stage because, obviously nobody wants to rip up a whole bunch of stuff after they made a mistake. And again, that puts a lot of, if we start bleeding into best practices, one of the big things that we're seeing is that people are doing a lot more analysis. On the order of 70% plus of designs, have 80% plus have some sort of form of signal integrity issues. Mm-hmm. 70% are doing analysis. So instead of doing a rule of thumb approach, they're doing some form of analysis, and it starts very early in the process. It's not just, hey, I'm going to do some analysis right before I send it to manufacturing. Even DFM checks, that was something that was typically done at manufacturing floor, let alone at the design stage. Mm-hmm. But even that's done throughout the entire process.
Do you see things like routing studies, like actually running, do all the differential pairs once and do all the match lengths and T-points? And I mean, just, trying to come up with the best strategy in order for the auto routing to accomplish what they want to, and the best breakout patterns, anything like that?
Yeah. That's, in terms of, placement studies, topology studies, but I mean, those sort of routing studies are even after what I'm talking about here.
Wow.
I'm talking about stuff at the engineering stage where they're sitting here saying, okay, what sort of power distribution topologies can I tolerate on this design? Can I work with? What am I going to do to get my SerDes lines in there? And they model in electrical, they model in thermal, they model in mechanical. All very early on before it's even really hit the layout stage. Mm-hmm. And so that obviously drives a lot of the constraints that go through the design process. But that's one thing, as a best practice that fundamentally you look at and you say, well, that takes extra time. Why would I want to do that? But again, what teams are saying again and again is, I did more analysis during the design process and I got a first time right design out.
Oh.
So that's the holy grail, right? Nobody wants to go through multiple prototypes, especially when they don't know what they're looking for if something doesn't work.
Yeah. And
so people are choosing as a best practice to deploy different forms of analysis tools, and there's tons that are out there. But to take that on to train up on those sorts of designs. And one of the things we looked at in terms of team dynamics, we asked people who's on your team, what do they do? And we saw it's pretty common now to see an SI specialist amongst the somebody who's identified as that SI or PI.
Yeah, I've been at big companies where they had a PI guy, a thermal guy, had
right.
An EMI guy. Mm-hmm. I mean, that really just took every aspect of that in each design.
Right,
so.
And that's that becomes a collaboration challenge as well, and that's in some cases we've seen design teams down to one, right, where you have one person driving from schematic through layout to to validation. And by the way, we see that with the TLA data as well. There are some teams where people do everything, and the trade-off of that versus the larger teams. Well, first of all, the benefit is that collaboration gets you specialization. You get teams that can people that can focus on stuff. The downside, of course, of collaboration is engineers have to work with each other, and so there are potentially some hiccups there in how they collaborate. How easy it is to do.
Mm-hmm. So, with the TLA submissions, do you get any insight into some of those collaboration methods that these teams have been using?
Yeah, sure. Specifically things like, electromechanical. People have been interacting with mechanical teams for decades. Of course, every product's had some kind of enclosure.
DXF.
There you go. Yeah. And there are better formats. IDF, by and large, is the most common one that everybody's using, EMN files or whatever you want to call them.
Right.
I don't see a lot of people doing, the newer technologies.
The ProStep, the IDX stuff?
Yeah, not much of that yet. But what I do see is that it's not as much of a, here I got to take a rule from mechanical. Here's my, here's my board outline. I have no choice. Mm-hmm. You see more iteration. There's more collaboration that goes on during the process. It's not a one-way thing. And likewise with manufacturing, stack ups, because of the performance criteria. Engineers are sitting there trying to work with manufacturing very early on to see if what they need in terms of performance can even be built and for what cost.
Right.
So that again is another iterative collaboration approach that I would call a best practice approach during the design process. I also see electrical specialists iterating with layout designers. We see cases, we had a few where somebody would say designing the FPGA at the same time as the board, or the ASIC at the same time as the board, or the package at the same time as the board, and that's a different kind of collaboration as well.
Nothing much funner than getting a new pin out.
Right.
4 weeks out from when it's supposed to go out the door.
Yeah, completely floors the whole thing. Right?
But it happens all the time.
Yeah, sure. By the way, we asked about ECOs because you talk about collaboration and concurrent design. Well, the most common concurrent design is between a schematic design and layout, right? Mm-hmm. You want to start the layout before the schematic's even done, and so some guys were talking about 100 ECOs during the design process, just to get the thing, and that's to be expected at some level.
That's where design synchronization and keeping those things
Right.
in sync really is important.
Right. In looking at the concurrent design between engineering and layout, again the trend for a long time, at least in larger teams, was that there was like 5 engineers to 1 layout designer, and that by itself kind of dictated some of the the collaboration that would go on. You only had one layout guy having to worry about stuff.
Mm-hmm.
Now, in some cases, we're seeing that drop. We also monitor the teams that way, and it's the average is closer to 2 to 1. So there's still more engineers, but in some cases we had teams that actually had more layout designers than engineers.
Wow.
And one can only presume that the makeup and the job responsibilities of those teams has shifted over the years, and that layout designers are taking on more engineering tasks, and to some degree the opposite as well. Engineers are taking on more layout.
Yeah.
They just have to enable those trade-offs and to be able to make the right decisions.
Well, you become a middleman at some point too.
Sure.
With the complexities of today's designs. This doesn't make sense.
Yeah, absolutely.
So, from the TLA entries, do you have any kind of idea of the smallest companies that may have submissions to this? Are they all larger, what we consider enterprise accounts?
No, it is. Well, they don't have to say how big they are. That's not one of the criteria. But you can judge from the logos, who's entering,
Mm-hmm.
and it's a lot. It's the full spectrum.
Okay.
You can also judge by the team size. When somebody says they have 30 people on a team,
there's your sign.
Yeah, right. Yeah.
Exactly.
But and then down to the teams of 1 or 2, right?
Okay.
Now even then, it doesn't mean that the company is small just because they have a small design team. It just means it's not their critical focus. But again, we saw the gamut of design team sizes and specialization within that team, and they all noted, as the teams got larger, they talked more about collaboration, how they accomplished it between the specialists and the design process.
Any big surprises from the entries that you got? Some comment or some process that you've never heard of before that kind of like, wow, that's kind of took you back?
Yeah, nothing of that was really shocking. I mean, it's always cool to look at what people are designing, and it's all again, it's stuff that we've all seen in the past. We've seen cameras in the past, but they're getting better. We've seen cars in the past, but the electronics in them is surpassing many other things. I think I talked some about on the layout, the PDNs. In terms of industries, really there's a crossover. There's a mutation to some degree of what we're seeing in the industries. We're seeing military designs, I said earlier, that are facing cost and time pressures. We asked folks to tell us what the secondary industry was. Okay, so here's your primary. Primary is military. What's your secondary? There were a lot that actually selected telecom. So it's mill applications for a telecom, or telecom for military applications.
Interesting.
That's the way to look at it. And the other one, industrial. Industrial designs are probably the fastest growing in terms of complexity out there. Again, industrial used to be the HVAC system in your home kind of electronics,
right.
not very complex, and now that category is growing on par almost with things like computer design, and there's a lot of crossover there.
What does that include?
In terms of performance, but consumer apps, mill crossover with industrial, telecom crossover with industrial, and so speeds and densities that are on par with some of the fastest telecoms.
Wow.
So maybe it's just what people call their designs, but again, it's not. There's really no laggard industry around anymore.
Wow. So a little bit more insight on densities of designs.
Okay. We looked at trends again over. We got all this data sitting in front of us. See, for those of you watching on video, data.
Just so the audience knows that part of this is being recorded. So, video promo. So that's what that means.
If you don't have audio, that's okay. You couldn't see it if you were watching on video anyway. It's what we call mouse font data. So anyway, looking at data, over the last 5 years, the layer counts have pretty much stayed the same, but the area has, the board area has dropped 29%, and the densities have gone up by 25%.
Wow.
So that's one example. Another one, over 20 years, The trace widths are down by about 40%, layers up by about 75%. The total area is down by 50%. So again, that density thing. The biggest thing, of course, is that density as measured by leads per inch is up 600%.
Wow.
So the densities are just going through the roof on these designs, and I think anybody doing design anymore would be able to reflect that. Over the course of their career, even if their career is only 5 years long, they're going to be able to talk about density increases on design. It's
So like a minimal trace? What is it?
the
Small component size?
the lines and spaces are kind of plateauing out at 4 and 4. That's the typical. Minimums 2 and 2.
Okay.
Now, that's like I said, over 20 years, that's down 40%. And you say, hey, well, that's big, but if you look at our silicon brethren, on the silicon side, their feature sizes have dropped 40 times.
Wow.
40x in the same time that PCBs have dropped 2x. So they've had to deal with a lot of challenges there in terms of densities as well. And of course, those densities, in terms of silicon integration, have had a lot to do with the impact at the board, right? In terms of in the potential for higher speeds, that's good, but it also introduces problems. The potential, along with those higher speeds, come more devices to help manage power, the capacitors that are out there, resistors to help with clean signals. And so the number of components has actually gone up as the number of ICs has gone down, just to help support that, that silicon integration. Again, another way to look at design density increase.
Well, that does it for today's discussion on design trends. Thanks, Dave, as always. Be sure to check out all of the podcast show notes. There you'll find any of the links that we refer to during the podcast, as well as the email address where you can send us your comments and questions. So please send those in. Again, I'm John McMillan, and thanks for listening. And be sure to subscribe to this podcast on iTunes or your favorite podcast app, and catch the next episode of PCB Tech Talk.